In this video, we're going to talk about supplemental examples for 5.8. So let's go ahead and get started here. This one is going to be in the form of an arctangent. We have du over a squared plus u squared, where just pull that 7 out front for right now. This is 2 squared plus 3 minus x squared, where a is equal to 2, u is equal to 3 minus x, du is going to be equal to a negative, and dx, negative, negative, like that. And so this is going to be negative 7, and then this is equal to 1 over a arctangent of u over a plus c. So this is over 2 arctangent of u over 2 plus c. If you want to, you don't have to leave it like this. Arctangent is an odd function, and you can pull that negative out, and it would look like this is the same answer. Let me show you why that is if we come back here. So let's come back to our original. So this is 7 over 4 plus, pull that negative out of there, is the same thing as like that is 2 squared plus x minus 3 squared. All the same setup there for what a and u is, but this is going to now be 7/2 arctangent of u is x minus 3 over a is 2 plus c, and we get the same answer. Just wanted you to see that if the answer you get in the back of the book doesn't have 3 minus x and has x minus 3, they factored out the -1, and that's why it became positive out there. All right, let's evaluate the indefinite integral here. There's an x on the outside here, and this is 4x squared minus 9 dx. Let's try our u substitution first, where no, that's not going to work. So this is going to have to be a arcsecant problem, where this is going to be secant the absolute value of u over a plus c. U is equal to 2x. du is 2 dx. So we're going to have to multiply by 2 and 1/2 here. A is equal to 3. So this is 1/2 times 1 over 3 arcsecant of absolute value of 2x over 3, and then all this is going to be evaluated from square root of 3 to 3. So this is 1/6 times arcsecant of 2 times 3 is 6 over 3 is 2, minus arcsecant of 2 times the square root of 3 over 3. So what this tells me is this is 1/6 arc cosine of 1/2 minus arc cosine of 2 over root 3. So that's root 3 over 2. I just think better in cosines than I do in secants, so I take the reciprocal. Cosine of pi over 3 is 1/2. This is pi over 3. Cosine of root 3, cosine of pi over 6 is root 3 over 2. So this is 1/6 of pi over 3 minus pi over 6 is pi over 6. And so that's pi over 36 for our answer. Now let's evaluate the definite integral here. U is equal to 1 plus e to the 2x. Du is going to be 2e to the 2x dx. So 2 and 1/2. This is 1/2 ln of 1 plus e to the 2x, since this is du over u. And this gets evaluated from 0 to, I think that's 10.5. No, that's ln of 5. Even nicer. All right, so 1/2 ln of the absolute value of 1 plus e to the 2 ln of 5 minus ln the absolute value 1 plus e to the 2 times 0, like that. So let's use our log properties here. 1 plus e to the ln of 5 squared plus e to the 0. This is 1/2 natural log of 1 plus, and then those will cancel each other out and give me 5 squared. Not cancel each other out, but undo one another because they're inverse functions. I'll just distribute my 1/2 here and get rid of those parentheses. So this is 1/2 ln of 26 minus 1/2 ln of 2. I'm going to say that this is ln of the square root of 26 minus ln of the square root of 2. Then use my log properties to say that this is root 26 divided by root 2 is ln of root 26 over 2 is ln of root 13 is the same thing as as 1/2 ln of 13. So I could have gotten that by splitting the 26 up into a 2 and 13, and the parts with the 2's would have canceled. Let me show you that. Could have turned into this. This and that would have made a 0, and I would have been left with that answer. Lots of different ways to work with logs to get the same answer. But this is the most broken down answer here that the textbook probably is going to give you. All right, let's find or evaluate the integral by completing the square. So integral of, we need to factor out a -2 here from the x squared part and also from the x part. leave that plus 4 over here by itself. Half of the middle number squared is going to be 4. So I just added a -8 into the problem, and I need to add a +8 right there to balance it out so that I did nothing. So now this looks like so. I'm going to rewrite this as 12 minus 2 times x minus 2 squared dx. And I don't like that common factor of 2 there. I want to take that out. So I want 6 minus x minus 2 squared like so. And I want a square root of 2 to come out here. So that's going to come out front like this. And then, let's see, we had, an indefinite integral there. So that's going to be, I'm just going to leave that as it is. I might rationalize it at the end if I need to, but right now u is equal to x minus 2. And I have du is going to be dx. And then I have a is equal to the square root of 6. So this is going to be arc sine. And so this is going to be arc sine, which doesn't have a 1 over a in front of it, of u over a plus c, like that. And so if you want to rationalize this, you can make this square root of 2 over 2 arc sine of x minus 2 over root 6 plus c, like that. And that's it for this video. That's also it for the supplemental examples for chapter 5. We'll come back next time and talk about supplemental examples from 7.1. See you for the next video.